So thank you very much for attending my talk, and I'll get something out of the way straight away. If you've got any Telstra jokes or comments about peering, rectifiers or exchange power, come and see me in the coffee break. If you can give me a joke that I haven't heard before, I'll give you a cookie. Okay, done. Is it in minutes, exactly. So, no, sorry. So before I start, my talk is on vendor support APIs. So let's do a quick hands up. Who uses vendor support APIs here currently? 1, 2, great audience, fantastic. So quick introduction. I've been with Telstra nearly 20 years, rotating through different IP networking groups, whether it's from MPLS to tiered or internal, and I go through all of them at the moment. I work on all of them. My current role is supporting a number of technical teams, doing end-to-end complex faults and creating automation. I'm also part of a special incident management group, working very closely with our domestic global operations centre. We get called in for any high priority or high severity faults across the business on a large amount of networks. And we're on call 1 week in every 4, and we get brought in to manage that incident. I describe myself as a technical incident manager. We can manage the incident and also on the tools, like a lot of you. And I hang out in Beer for Peer and also the Edge IX Discord for chat. So with vendor APIs, what is it? It's between your company and the vendor. And this can be for automated information and requests. Now, the communication between the communication with your devices can be done a large number of ways, whether it's Python, Ansible, Salt, it doesn't really matter. But the talk today is about how you communicate with the vendor using APIs. So let's talk a little bit about the problem. When we have a power supply or another hardware component fail, the process to raise it with the vendor is traditionally time-consuming, and we've probably all done it. Once we get a power supply failed alarm or a module fail, we log on to the device manually, we confirm the failure, then we grab the serial numbers, and then we log on to the vendor portal, we write up the problem, we click submit, and then we wait. Then once that part is finally delivered, we need to raise a job for our technicians or remote hands to go out and replace it. And this model is very repetitive, and there's a high potential for automation. Now, I'll just hold on. Above, I've got an overview of the maturity levels there. So at the top, we've got manual vendor support, self-sparing, and then automated vendor support. And down the bottom there, we have Lincoln and his AWS team creating their own devices. So let's run through some of the API options that the major vendors do offer that you can use. So firstly, Juniper. Juniper has an extensive support API suite, including ones for asset management, case management, end-of-life data, and also service quotes. The documentation that Juniper provide is quite good with examples of each API, the options and variables you can have. It also features Swagger and open API files for easy integration. Now, some of the APIs they provide, I've listed there, case management, and they also, with the case management, you can do create, update, close, and you can also query certain parts of the case, whether it's getting the work log notes or whether it's getting the details about the RMA. With CISCO, they have a number of security options to secure the API. They also have a totally separate dev sandpit environment, which is really nice when setting up. Yeah, you can query their fake data to make sure everything is good for production. For onboarding the API, it's currently via the URL mentioned there, and it's manually set up by the Juniper API team. So second, CISCO. CISCO has an extensive support API as well, including ones for asset management, case management, end-of-life data, and service quotes. While the case management API does have a number of really, really great features, at the current time, the ability to raise CISCO cases is via another API called Smart Bonding or Smart Grid. And CISCO have a really nice serial number to information feature that provides details about whether that serial number is supported or not, and what information does CISCO know about that serial number. With CISCO, they also have a number of options to secure the API, but with CISCO, they operate a self-serve model, so you can go in and create the APIs yourself. But it's a little complex, so let me step through it and explain it. So with CISCO, there is a three-stage approach to undertake the self-service to create your own API keys. So firstly, you need to get company administrators set up. Now, this is done by your CISCO account reps, and it's added to your total SmartNet accounts. So what that means is if you have a support contract with CISCO, it's a total SmartNet account. Then those company administrators can log in to the CISCO Access Support Management website, or CSAM website, and they assign roles to each user, or and by user I mean someone with a CCO account. Then from there, anyone with API developer permissions can log in to another website, which is the API console website, which is where you create your keys and secret for each API. So this is an example of going through the CISCO API in Postman. So we're using the client ID and client secret that we configured in the API console, and we use it to send a token request. So the example here, the token is AusNOG is awesome. Then, using Postman again, we grab that token and we can use it as part of our request to send an API information request. So we're using it in the authorization with Postman, and we've got the URL, which is a serial number to information query. When testing this against a production Telstra node, sometimes we do get very surprising results. So in this case, it's showing one of our devices is either owned or was brought by Walmart, and it just goes to show you can get everything from Walmart. Another vendor, F5. So the My F5 support platform is planning to be updated with API capability and is a high priority for F5. There is also a new version of big IP software coming later this year, which will allow customers to use Central Manager and automatically upload the QK or Showtech to the My F5 support portal automatically. Now, in discussions with F5, they say they are always taking feedback about how to make things easier using the My F5 support portal. So if you have a big F5 fleet and you'd like to see automation flows, please provide some feedback to them via the URL in the slide to say you'd like APIs or you'd like something, because without them telling us, they're not going to build it. Next one's Nokia. Nokia are currently trialling a B2B integration with customer ticketing systems. They have a current a system where fault requests can be raised via an API-like email system, and that can be easily automated as the variables are worked out by you and Nokia about what to expect, when to expect it, leading to somewhat automated case creation. So let's talk a little bit about the Telstra Zero Touch journey. So we were given the task to automate tickets which were taking a lot of time. And one of the examples we were asked to look at was Juniper MX power supplies and make them zero touch. Because when we were given these things were absolutely killing us. We're having lots of power supply failures. It was taking lots of time, lots of manual work, and it's really, really annoying. And it sounds really easy. Just go automate it. And if you say it fast, it does actually sound really easy. just go do it. Just make it happen. But what we found out is that the building blocks that we needed to make this occur didn't exist at all. We didn't, at that time, we didn't have an API to Juniper. We didn't have a small database for job tracking. And we didn't have a method for Telstra field tasks to have it delivered at one location and then go installed at another location. So we started designing a system that had a couple of aims. It had to be multi-platform. So for us, it didn't matter where our Juniper MX router was being used or what it was doing, whether it was layer 2, layer 3, BNG, or in any of the numerous Telstra networks. We wanted a solution that could work for all of it. Hang on. Oop. How do you go down? Please scroll down. I'll make it work. Okay. Now, we called this solution Juniper Auto Tac. So we nicknamed it, and then we started building the specific components required for it. So gradually, we have built all the required building blocks. So first, we built an API to Juniper, which was great. You could do it manually. It could create a Juniper case or Juniper JTAC case, which is great. But we didn't really have the components surrounding it to make it a full solution. Then we built Python scripts to log on to our specific nodes in the networks to grab the required information. Then we created a small database to track the status of our jobs, to find had we created a case, had that part been delivered, and what was the status of it. Then we created the Telstra field tasks, so we were able to send the part to one location and then have a technician pick it up from there and go install it at another location, or install it at the location it was delivered, depending on where the device was. Just recently, we've built a data center module that automatically arranges access to our data centers for staff replacing these power supplies. And this has actually opened up more devices for us because we can automatically get into the location and have all those devices within scope. So we have two major components to our current solution. Firstly, when the power supply does fail, we intercept the power supply down trap, and then we straight away create an internal ticket. Then we trigger our Python automation to log on to our devices, find serial numbers, find models, find locations, and find the delivery locations as well. And then what we're able to do from that, we're able to automatically create a JTAC case via API with all that information enriched and send it up and have it created. Then every 2 hours, we have an automatic job that runs that queries all our open cases to find the status of the part delivery. And if that part has been delivered, then what we do is automatically raise a job for our remote hands or Telstra technician to pick up that part and go out and replace it. So let's actually have a look under the hood and see how it works in a technical point of view. So on here, first of all, the blue up there, that's our orchestration system. Now, Telstra uses a Node-RED-based orchestration system, and we really like Node-RED because we've been able to build modules to interact with different Telstra systems, and it's very customizable that we can build more features into it. So using that orchestration system, we intercept the power supply down alarm, we create an internal ticket, then we find the location of the device and the delivery location of the device. And both of these are just statically defined because our devices are not going to grow legs, they're not going to move, hence we don't need to update that too much, and we only need to update it for new devices. Once we have that information, we then log on to the devices to find what power supply is faulty. So for a Juniper one, it's a PEM, so we find what PEM is faulty. Then, depending on that PEM, we grab some outputs, including show chassis power, and we grab environmental commands, and we also grab the serial number information. Then we send it back to our orchestration system, and from there we can create the JTAC case. Now, when we do create that JTAC case, it's created in a templated, standard manner. So we create it with, we say this is an automated case, we show the outputs, we say we are requesting RMA, this is the serial number, this is the model number, and this is the delivery address. Because we say that we've checked the power, we've checked the circuit breaker, we've reseated it, we've done all that. And the reason for that is really simple. It's more cost effective for us to have one technician visit with the part and discover it's a circuit breaker, or if it's not the circuit breaker, they have the part to replace it. If it is the circuit breaker, fantastic, we just return the part unused. So for us, it comes down to a matter of efficiency, and it's, from a cost point of view, it's much better for us. Now, we've had to update this template that we use for Juniper a couple of times. We used to give them the street address and everything like that, and then they started asking us, what country is New South Wales in? So we now say it's in Australia. Another one, when we deliver it, we generally just say deliver it between 9 and 4 to the site, business hours. And then they start asking us, what time zone is that in? Okay, so now we have to modify our template to say local time. And our aim is when we raise these cases, Juniper just give us the RMA. I don't want to have a big discussion about troubleshooting or trying that power supply in a different node or anything like that. The aim for us is just to get that RMA sent as quickly as possible. Now, with the second part, what we do, it runs a simple job that runs every 2 hours, and we're able to query the service request to see whether an RMA has been created. And then if an RMA has been created, we then do a subsequent RMA call called query RMA. And what we're looking for is a specific field in there that says RMA delivered closed. And that's under the replacement status one. And if we see that, we know that the part is there, waiting, ready to go for your remote hands or your technician. And from that, we then trigger a flow to automatically close the Juniper case, and we update it to say, part delivered, thanks very much, close it, please. And then we can trigger a flow for remote hands or your field technicians. When we trigger the field technician flow, that's fully automated. We grab all the details about the part from the API. So we grab the new serial number, we grab the tracking details, we grab who it was received by. All those details allow us to create automated jobs, and it reduces the chances of error and also problems down the track. So let's see what this looks like in real life. So this is a production Telstra flow. We have intercepted the power supply down alarm, and we've created an internal ticket. So you can see it's one of our aggregation nodes. From there, we've called our Python automation to enrich it with all the details, and then we've sent it back and created the Juniper case. Between the ticket being created and the Juniper case being created, it's a total of 50 seconds. And then from there, every 2 hours, we are monitoring to see, has the RMA been created, and also has the part been delivered. So in step 2 there, we're doing a check of the API to see whether the RMA has been created. And you can see there it says, API checks show that the RMA hasn't been created as yet. Then on step 3, what we do is see, it continuously checks it, and we can see that the RMA number is now there, but the part has not been delivered as yet. So it's still in transit. So on step 4 here, it's detected that the RMA exists and the part has been delivered. So then we trigger the flow to automatically close the Juniper case. And then we arrange the job for a remote hands or Telstra technician to go out and grab that part and then replace it. And in step 7, we have our technician call into our NOC to say, I have the part, I'm in front of the device, I'm ready to go. And that part was successfully replaced and we closed our job. So in this case, the power supply replacement was 99% zero touch. The only engagement that we had from a human was A, the physical person on site doing the work with the part, and B, when he called into our NOC to say, hey, I'm ready to go. So where are we with our Juniper Auto Attack solution? We have about 300 MX devices enabled for it across the business with various functions. If I find a Juniper MX device in the network that's not in here, I quickly include it because we want all our devices to be included. At the moment, we have 12% of our routing and switching cases are raised by the API. So this is 12% of routing and switching across Telstra. And that's 12% of Juniper cases that we go to Juniper for assistance. Now, with all these cases, they are 99% zero touch with no operator involvement until the tech's on site with the part. Now, with our next steps, we really want to include more hardware components, fan trays, FPCs, rectifiers, with the target of 25% of our routing and switching cases being raised by API and being fully API automated. Now, as part of our learnings and outcomes, when I first got asked to do this, I didn't think it was possible. But I stand here to say, yes, it can be done and it works very well. Slowly, we have broken down the steps involved and automated them to now have a mature, automated solution. We are seeing reduced mean time to restore and reduced human touch. Now, at the moment, we're only touching power supplies as yet, but this could be very easily integrated for customer impacting modules, or other customer impacting stuff, or customer facing optics, or anything, any Juniper component that you want. This could be a very easy solution that you could integrate through. And that also means that your customers could see quicker restore times, because as soon as that part's delivered, you are getting your remote hands to get it out, get it replaced with no delays. Now, this is something that you could replicate in your network operations center as well. And if you have a medium to large number of network devices, there is a lot of potential for hardware replacements to be fully automated. The more devices that this can be enabled on, the more cost-effective it is, not only from a vendor point of view, but also from a service provider or ISP point of view, because you're reducing your need for your operators to work on some of these things. Now, we've got a couple of learnings that were found. One of our learnings is start small, but think big. So we broke this into very small, workable chunks. We created a small database. We created some scripts. Slowly, these small things have come together for a very mature solution. The other one is, if you're looking at doing this, aim to have one interface to the vendor, because there's nothing worse than mushrooms popping up all through your organisation doing very, very similar thing. In our occasion, we have a number of different business units all funneling their Juniper API stuff through our one interface, allowing us to control it and also allowing us to have a much more efficient view. The other one is consider vendor selection with your tenders. If you undertake an automated solution like this, your operators can focus on other things. If you bring in a vendor that doesn't have support APIs or needs everything manually, you need to look at the staffing consequences of that. So in the medium term, we are looking at deploying CISCO AutoTAC, F5 AutoTAC. So manual hardware replacements for these vendors are a thing of the past. We want to see more vendors deploying support APIs to allow customers to check information automatically and allow case creations in an automated fashion. Now, what I've discussed today is not a complete list of all vendors, but rather a small sample that we work with or can see in the industry. For the longer term, I believe we really need to scale this up or to change. At the moment, we have these cases being raised by automation on the Telstra side, and then being looked at by a human on the vendor side. We want to see this evolve so that Telstra automation can talk to the vendor automation and the RMA be validated and then automatically dispatched, freeing up both operators from an ISP point of view and also from a vendor point of view. We're really excited about some of the opportunities that may exist with Juniper Support Insights or some of the CISCO products that may integrate machine learning or AI ops or Quick to ensure this is much more mature and evolved. Now, it wouldn't be a Telstra presentation without a reminder about 3G. Now, 3G network is closing in June next year, less than 12 months away. Now, while everyone here is a good network operator, please ensure an audit is undertaken to ensure no production 3G devices. Now, this could include out-of-band connections, M2M, FPOS terminals, environmental monitoring, anything and everything. It could even include production mobile devices sitting in cupboards and not touched for many, many years because they just keep working. They won't be next year. Now, everything needs to be checked to avoid future outages when the 3G closure occurs. Now, Telstra really appreciates the proactive work from the community, which goes a long way to making sure this big change is easier on all customers. Now, in summary, support APIs is great from a vendor point of view, where you can reduce the staffing or dealing with the manual. It's also great from a network operator point of view, because it'll allow your staff to not worry about these hardware components and have everything automated. Now, love to chat in the coffee break and take some questions about it as well.